Welcome back. We are going to finish up our study of histology by looking at how tissues grow, how they repair themselves, and how they die. So we've already talked about different types of tissues. We've talked about specific conglomerations of tissues like glands and membranes. And now we have to look at sort of the lifespan of tissues. So we're going to start at the beginning with stem cells. You usually hear about stem cells in the idea that they can become anything. That's their claim to fame. And really, there are two qualities to stem cells that make them so important. The first we're going to look at is the quality of self-renewal. When a stem cell divides, two cells do not move on. Okay, so it's not like your normal mitosis. One cell moves on and differentiates, the other self-renews. This means that we will always have the ability to keep going through this pathway. So self-renewal is the first thing that is so important about these. The second quality is the whole you can be anything you want. Kind of. So there are levels to this quality. Very, very early on, right after fertilization, we're talking within a couple days, we have what are called totipotent stem cells. They are the most plastic of all of the cells. They can become anything in the embryo and any of the extra embryonic membranes needed for pregnancy. So they have the most stability. That quality leaves very early. By the time we're talking maybe 5 to 6 days post-fertilization, our stem cells have dropped to what's called pluripotent. Now they can become anything in the embryo, but they can't go back and form a portion of the placenta. So that's an important distinction. Once a cell takes a step forward, it cannot take a step backwards in its differentiation. So you start off with totipotent for a very short period of time, and then we move on to pluripotent. Now, pluripotent are still incredibly plastic. They can become any cell. So they could become a nerve cell, they could become a muscle cell, they could become any type of epithelial cell, they can become any type of connective cell. So any of our four tissues, they could become them. When you hear about embryonic stem cells, for research purposes, generally speaking, they are talking about pluripotent embryonic stem cells that occur at roughly 5 days post-fertilization. From there, your stem cells are going to continue the process of differentiation. And every time they take a step forward, they can't go back. Okay, so remember we've got our self-renewal. Here's our self-renewal. But every time we take a step forward, we can't go backwards. Adults have what are called multipotent or slightly plastic stem cells. We absolutely have stem cells, but they are committed to a particular cell line. And again, you can't go back. So for example, we have these cells, hematopoietic stem cells, in our bone marrow. They can differentiate into multiple different types of blood cells, but they can only become a blood cell. They can't go back and go, no, I think I'm going to be a neuron. Doesn't work that way. Okay. So adults have multipotent stem cells, and then unipotent is something like the stem cells you find in your skin. They can only become one cell type, so a keratinocyte. That's the only thing that they can become. So they replace themselves, so they're still stem cells because they have the quality of self-renewal, which allows us to continue the process of cell division constantly and renewal, but they can only become one cell. So adults have multipotent and unipotent stem cells. So there's not a huge amount of plasticity in the adult stem cell populations. They are very committed to what they're going to be. So the growth of tissue essentially is going to happen in one of two ways. Hypertrophy is when the number of cells stay the same, but the cells get bigger. Cells that cannot undergo mitosis do this. Cardiac muscle, skeletal muscle, um, they don't divide. They don't go through mitosis after a certain period of time. So when you go and you work out your biceps at the gym by lifting heavy things over and over and over again, you're not making more cells, you're making the cells you have bigger. The other way that cells or a tissue can grow is to increase the number of cells. This is called hyperplasia. So here you started out with 4 cells, now we have 6 cells. Most of your growth and development through infancy, childhood, things like that is going to occur through hyperplasia. You certainly have more cells in your body now than you did when you were an infant. But these are basically the 2 ways that tissues can grow. Now, whether they choose one or the other is going to depend on how readily they can undergo the cell cycle. If something can undergo the cell cycle very easily, then hyperplasia is going to be the way it goes. But if it can't divide, hypertrophy or hypertrophy is going to be. So tissue repair is going to depend on the tissue, how well we can do this. Some have a really high capability to regenerate. Things like your epithelium, things like your skin, okay, that's epithelium. Bone, areolar connective tissue, dense irregular connective tissue, blood-forming tissues, these all have a really high capability of regeneration. So here is an example with your skin. You cut yourself. Major thing that needs to happen for regeneration to occur is you need a blood supply to come in. This is where it went there for a second, get all of our blood cells that are going to come in to fight off any infection, but it's also where we're going to get things like growth factors and the scaffolding needed to begin to make new tissue. You end up with what's called granulation tissue that starts to form from the bottom up. You'll get a scab on the surface that's going to protect the underlying tissue. And then eventually, because this tissue has the ability, you will repair the tissue and usually have some degree of fibrosis or scar tissue. Just depends on, a lot of that is just your genetics as to how much you scar when you have tissue injury. So something like this, really capable of undergoing repair, which is important. I mean, we damage our skin pretty much daily. Whether you see it or it's microscopic, this is happening pretty much all the time. Now, moderate capability would be something like smooth muscle and dense regular connective tissue. So if you remember, dense regular connective tissue makes up tendons and ligaments. So, I mean, if anybody's ever blown out their knee, they know it's not the greatest. But there is an ability to fix it. It's going to take a really long time, though. Very weak capability would be skeletal muscle and cartilage. If you tear all the ligaments in your knee, that's one thing. If you tear the cartilage, the meniscus of your knee, it pretty much never heals. It doesn't have a blood supply. And skeletal muscle falls into this category as well. It tends to just fill in with scar tissue, which is non-functional. So you pretty much just don't have a good capability to repair here. Zero capability is cardiac muscle and nervous tissue in the central nervous system. If you damage your brain or your spinal cord, it doesn't fix itself. If you damage your heart, if you have a heart attack, cardiac muscle doesn't divide, so it doesn't have any ability to fix itself. So those are permanent injuries to the tissue. So not every tissue can repair itself. Some can, some sort of can, and then some just simply cannot. The last thing to talk about is how tissues die, and we basically have 2 different pathways. Apoptosis is a neat and orderly death of the cell. Everything is going to happen from the inside. The cell triggers its own death. Everything basically just begins to in a very ordered fashion, break down. It's imagining like if your cell was a building and you wanted to take the building down. It's like when they implode a casino in Las Vegas. If you ever watched that on TV, it all just falls neatly down into a pile. And then trucks come in and they begin to pull the things out of it. There's no collateral damage. You don't have bricks flying all over the place. Apoptosis is what's called programmed cell death. And if possible, that's how we want our cells to die. We want our cells to simply go, okay, I've divided enough, or, oh, I have a problem. I'm going to go ahead and kill myself now. Okay. The other way is necrosis. This is a messy way for the cell to die. Nothing is neat, nothing is orderly. It's usually due to infective processes, and in all likelihood, it's going to harm the neighboring cells as well. So, generally speaking, we always want to lean toward apoptosis. We want to stay away from necrosis in terms of the death of our tissues.